In this video, we're going to do an example problem that uses both conservation of energy and conservation of momentum. So in this problem, a cart of mass 10 kilograms starts from rest on a track at the top of an 8.10 meter high hill. The cart starts to move down the hill and hits another cart that's on the same track that was moving directly toward the first cart at the bottom of the hill with a velocity of magnitude 3.05 meters per second. If the two carts stick together and the second cart has a mass of 11 kilograms, what is the magnitude and direction of their final velocity? Okay, so there's kind of a lot here, so let's break this down and see what we have. We have this first cart, it's starting from a rest. That means its initial velocity, so we'll call this cart 1. Initial velocity of cart 1 is 0 meters per second. And then we're told that the hill is 8.10 meters high. So the height of this cart is initially 8.10 meters. And then down here at the bottom of the hill, the height is 0 meters. Call this height 2. And this is cart 2. And we're told that this cart is moving toward the hill and toward the other cart with a velocity magnitude of 3.05 meters per second. So the magnitude is 3.05 meters per second. However, it's going in the opposite direction of the other cart. So the velocity of cart 2 is initially negative 3.05 meters per second. We're considering the direction to the right as positive and to the left as negative, and that's important in these problems. Okay, and then we have the two masses for the two carts. So mass 1 is 10.0 kilograms. Mass 2 is 11.0 kilograms. So we have to break this up into two different parts. One where we're using the conservation of energy, and the other part we're going to use conservation of momentum. So what we need to do first is to figure out the velocity of the second cart once it reaches the bottom of the hill. So once it is down here, this drawing is not perfect, it's going to be going toward the right, so it's going to have a positive velocity, but we need to know what that is. As far as the first part of this problem, we're going to call this velocity V final 1. So this is still cart 1. But it's the velocity for the final part of the first part of the problem. So first let's use conservation of energy for cart 1. Okay, so initially our cart is at the top of a hill and it's got no kinetic energy because its velocity is 0. So kinetic energy is 1/2 mv squared, v is 0, kinetic energy is 0. But it has a gravitational potential energy of mgh. So this is h1 and the mass is mass 1. So this is its total energy initially when it's at the top. And this has to equal its total energy at the bottom of the hill, where we now have a height of 0 and we have some velocity that we need to find. So our height is 0, so there's no gravitational potential energy when cart 1 is at the bottom of the hill. So we just have kinetic energy 1/2 m1 v final 1 squared. Okay, so now we can just solve for the velocity here, right? So mass 1 is on both sides. We actually don't need to include this. It will cancel out. So we just need to solve for v final 1. So we're going to multiply through by 2 to get rid of the 1/2 on the right. And we are going to take the square root of both sides since we have velocity squared. So that's going to end up giving us 2gh1. We take the square root. So this is how we can get our final velocity for cart 1 at the bottom of the hill. And just plug in these values. So 2 times g, which of course is 9.81 meters per second squared for the acceleration due to gravity. And our height one is 8.10 meters. And that's going to give us a velocity of positive 12.6 meters per second. So this is the velocity of cart 1 at the bottom of the hill. Now we can move on to finding the velocity of the two carts once they hit each other and start moving together. So this is the conservation of momentum part. And this involves both carts. Conservation of energy part just involved cart 1. Now this has to be both carts. So they're going to combine the momentum, both carts. All right, so initially we have this situation here, right? So we know the velocities that they're each going initially. V final 1, which is now going to be the initial velocity again for cart 1 for this part, is 12.6 meters per second, and the initial velocity for cart 2 is negative 3.05 meters per second. So the momentum, of course, is P equals mv. So each cart has its own momentum initially. So we have m1 times v initial 1, which is this velocity. So it was the final velocity in the first part. It's the initial velocity for cart 1 in the second part, plus the momentum of cart 2, which is m2 times v initial 2. So this is the total momentum of the system initially. And this has to equal the total momentum after they stick together and start moving together. So that's going to be m1 plus m2. So they're sticking together, so they're moving together at the same velocity, which we'll just call v final. It's for both carts. So we want to solve for this v final. We're just going to divide both sides by this m1 plus m2. And that's going to give us v final equals m1 v initial 1 plus m2 v initial 2 divided by m1 plus m2. Now we can go ahead and plug in the different values for these variables. So that's m1 is 10 kilograms times 12.6 meters per second plus 11 kilograms times negative 3. I keep having to move this over. 3.05 meters per second divided by m1 plus m2. That's just 10 kilograms plus 11 kilograms. Now, that's going to give us a final velocity for both of positive 4.40 meters per second. So after they stick together, they're going to move together to the right at a velocity of 4.40 meters per second. Now, it's less than the initial velocity of the first cart when it's at the bottom of the hill, because the second card going the opposite direction slows it down. So we do need to make sure we take into account this this negative sign for the initial velocity of cart 2. So we end up subtracting this term. So that's how we do one of these problems where we're combining conservation of energy and momentum. So hopefully that was helpful, and thanks for watching.